Hi colleagues, welcome to Math Art Institute. We are going to look at testing for optimality today, alright, and we're going to use the MODI method or modified distribution method. Alright, so we have a particular question or solution, an initial feasible solution on the screen, and we are assuming that we got this solution using the least cost method. So from having the initial feasible solution, we need to test for optimality. What is optimality testing? We're just trying to see whether or prove whether the particular solution we have is the best solution we could ever get, or we could actually adjust it to a better solution, right? So that is about optimality testing, and we can test for optimality using modified distribution method, which is also called MODI or UV method. We could also use the stepping stone method, but in this case we're going to use MODI. Alright, so what do we need to do as a first step? We need to test whether the particular solution is a non-degenerate problem or not, right? So, and how do we do that? We say number of allocation, so allocated cells, should be equal to number of rows plus number of columns in brackets minus 1. Alright, so how many rows have we allocated? We have 1, 2, 3, 4, 5, 6. So we have 6 allocated cells is equal to how many number of rows do we have? 1, 2, 3. We have 3 plus how many columns? 1, 2, 3, 4. We have 4, right? Minus 1. So we know that 3 plus 4 is 7 minus 1, that is 6, and we have 6 is equal to 6. And we have tested that this particular problem is a non-degenerate problem or solution. So having a non-degenerate solution takes us to the next stage, alright? If you find a degenerate solution, meaning you cannot proceed, okay? But since we have this particular solution as a non-degenerate, where the number of allocated cells are equal to m plus n minus 1, so it means we can proceed. Right, we start making some assumptions, alright? So the second stage, you let your columns be equal to u, right? So you have a u there, those are your rows. Sorry, you let your rows equal to u and you let your columns equal to v. So these columns are equal to v. So that means since this one is a first row, is going to be u1, second row is going to be u2 and u3 respectively. Same applies to the columns, column 1, column 2, column 3, and column 4. All right. Now, having done that, you need to calculate the value of v and u, right? Or u and v. And that is why this method sometimes is called the UV method, right? Because you are letting these variables to be u and v. Okay, so using a particular formula which would be ui plus vj is equal to cij. So this denotes a particular cell, and this denotes whether that falls in the first column or the second column. All right. Now this formula is for allocated cells, so you do this for allocated cells, and you make another assumption. Other than making that assumption of letting those to be u and v, you make another assumption where you let your u1 equal to 0. So always make that assumption that u1 should be equal to 0. So now you go to allocated cells. You know that the red numbers that we have put there are allocations, right? The quantities we have allocated, while the smaller numbers there are costs attached to those movements from a particular source to a particular destination. All right. So we have this cell 1, 2, right? Because it's falling in this first row and second column. So we are calling that one as C 1, 2, right? So how do we get that? This particular cell that has a 300 is in U1, so row 1, and it is in V2, right? It is in V2 and U1. So we're going to add U1 plus V2 equal to the cost attached, which is 1. So we are going to say U1 plus V2 is equal to that cost there, which is 1. All right, what is the value of u1? We have made this assumption to say let u1 be equal to 0, so we are going to place 0 there, plus v2 is equal to 1. So that means v2 is going to be equal to 1, isn't it? All right, so we do that for all the other allocated cells that we have. So because we know the value of v2, it will be easier for us to get the value of cell 3, comma 2. Why? Because it is in row 3 and column 2. So we get that now, because this 50 allocated 50 here is falling in this particular cell that has a cost of 3. So we get u3 plus v2, right? So we say u3 plus v2 is equal to that. What cost do we have there? We have a cost of 3. So we have a cost of 3. And from there, we say, okay, what is u3? We do not know, plus v2. V2, we've just found it here, which is 1. So we say equal to 3, right? So u3 is going to be equal to 3 minus 1, because the 1 will cross over the equal sign and it will be a negative. So u3 is now going to be equal to 2. All right, we are progressing well, isn't it? All right, from there, you know that since you know the value of u3, so you can find everything else that is in u3, right? Which is the 250 there and the 200. All right, so if we pick the 250 cell there, which is cell 3, 3, all right? So meaning the variables that you have there is u3 plus v3 is equal to, what cost do we have? We have a cost of 3 also. All right, so we are going to say equal to 3. So u3, we calculated it as 2, isn't it? 2 plus v3 is equal to 3. So this will cross over the equal sign. We'll have v3 is equal to 3 minus 2. And v3 is going to be equal to, what do we have there? Equal to 1, isn't it? All right, we move forward. Since we found this, I'm going to tick with a black pen for those that we have calculated. We've calculated this one, we've calculated this one, and we are just from calculating this one. All right, so we go to this one that has a 20 there, which is cell 3, 4, right? u3 v4. All right, let's go to that one. So let me just use here. So we are adding u3 plus v4 is going to give us a 2 there as a cost. u3, we calculated u3 already as 2. So 2 plus v4 is equal to 2. And this will cross over the equal sign. So you are going to have 2 minus 2, isn't it? And v4 is going to be equal to 0. All right. We have also calculated this one. So how many are remaining? 2 are remaining. So now since we know what v3 is, we are able to calculate this cell that has the cell that has this particular 150 there. All right, so that is in u2 v3, isn't it? u2 v3. So you are going to say oopsie, what's happening? u2 plus v3 is equal to, what's the cost in that cell? That's 5. All right, is equal to 5. So u2 is 1 plus no, u2 we do not know. u2 we do not know. So u2 remains u2. But v3, where is v3? Did we calculate? Did we find the value of v3? We should have. All right, this is v3 actually. You see v3, which was 1. All right, so u2 plus v3, and v3 in this case is 1. So we replace it by that value. 1 is equal to 5. So u2 is going to be 5 minus 1. u2 is equal to 4. All right. All right. What else? So we tick this one because we have done it. We are remaining with this cell. So this cell is u2 v1. All right. So we are going to add u2 2 plus V1 is equal to, what's the value of the cell? The value of the cell is 2, right? So is equal to 2. So U2, we are just from calculating it, it is equal to 4 there. Alright, I should have used the red ink there. Alright, so that was equal to 4, so we replace it by 4 or with 4 plus V1 is equal to 2. So V1 is equal to 2 minus 4. So V1 is going to be negative 2. Alright, we have done the second part. Alright, this is the second part. We go to the third part, the third and final part. Alright, and the remainder will be just reiterations. Alright, so watch the next video that does the last part. Alright, so this is where we're going to leave it from, and the next video is going to complete the whole cycle. Alright, see you in the next video. Thanks.